Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, CloudOps, Achieving Continuously Optimized Cloud Infrastructure, brought to you by Spot by NetApp. We have a great webinar for you today, but before we get started, I just need to go through some quick housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit DevOps.com and you'll find the webinar there. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Also, if you look in the handout section, you'll find 3 PDFs that have been made available for you to download and read at your own leisure. And finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards. So stay tuned until the end to see if you're a winner. Joining me today is Tomer Hadassi, Head of Strategy at Spot by NetApp. Hi, how are you?
Hi, I'm doing great. How are you, Julio? Thank you for having me.
Excellent. Oh, thank you. From what I understand, it's nighttime, so we all appreciate you taking the time.
Of course, it's my pleasure.
Great. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Perfect. So thank you again, Julio. Nice to meet everyone, or not meet. Thank you for joining us today. It's a pleasure that today I'm going to be talking to you about the world of CloudOps and how continuous optimization can help you operate your cloud better. How you can get the most out of your cloud and the most value and extract the most benefits out of it while keeping the best unit economics possible and the best cost models at all times. I come from Spot by NetApp. We at Spot believe that it's important to give your workloads the cloud infrastructure that they deserve, one that is always available, always scalable, and always at the lowest possible cost. Now, it's important, first of all, kind of getting the big picture. Why did we all adopt cloud? Why did we all move to the cloud? Cloud's main message to the world wasn't, hey, this is cheaper, right? Like, that's not why we're there. But it was more about developer productivity, avoiding outages and relying on the massive scale that the public cloud providers can bring, avoiding capex of buying expensive data center and paying for actually what you use and kind of OpEx over time. Be safer around data breaches. Again, a shared responsibility model. So, one could argue otherwise, but it is that it's nearly impossible to penetrate the public cloud data centers, even if it is sometimes possible to get into your VPC perimeters. Still, you're relying on hardware and on underlying infrastructure that is extremely secure. Total cost of ownership, hopefully over time, you are able to reduce it and gain more bang for your buck. Especially for businesses with cyclical behaviors, right? So if you're operating more heavily during tax season or during Black Friday or holiday season, when you were building a data center, you had to build it for those periods and only use 20% of it in the rest of the year. Cloud gives you the opportunity to use what you need when you need it. And of course, at the core of it all was agility. The ability to optimize your time to market and kind of help your developers move faster and more efficiently. I believe audio should be available without dial-in. Julio, if you want to take that. Now, all of that does come with a cost, right? So if you look at like the migration graphs of moving from your data center to the cloud, you kind of see this graph of, you have like 2 or 3 years, so your IT spend actually significantly goes up because you're paying for cloud infrastructure and you're still, amortizing or spending capex on your data centers. And really, the goal is that eventually it becomes cheaper. But I think that with continuous optimization and with the right mindset and the right tools in place, it can be cheaper from day one, at least at the unit economics level. And if you're able to shut things off in the data center or your footprint is expanding as a business, you'll be able to do so while improving unit economics and not worsening them. Now, when we think about savings can come from either hard savings or soft savings. Hard savings means, really reducing how much you spend on compute, storage, network, security, kind of all of the layers and pillars of your cloud infrastructure. The other one is avoiding the cost of hardware and software purchases that are extremely expensive and leveraging more SaaS models or infrastructure service models. Reducing operational costs like backup, disaster recovery, and everything around data management, essentially. And reduction in operation-oriented personnel. I think it was Reed Hastings that when asked why did Netflix move into the cloud, he said, we're not in the business of managing data centers, we're in the business of providing content and entertainment. And it didn't make sense for us to keep so many co-locations and build those massive layers of infrastructure when someone offers that as a service, and we as a business can focus on how we differentiate and how we provide value to our, today over 100 million customers. Now, when we think about soft savings, we think about reusing applications and services that, allows you to remove overhead. So if you can use the same platform or use a shared Kubernetes environment for different teams in your organization, maybe you can more efficiently pack your infrastructure. You can increase your developers' productivity. If because you're moving faster, you're churning out 10% more code, or 10% more features, which in turn translates to more revenue, this developer productivity might be more important than reducing your cloud spend right now. Or again, if your cloud spend is efficient, the fact that you're spending more is not necessarily a bad thing. And many times it can be great news. It means you're getting more traffic, more work, more customers. You can improve customer satisfaction. Again, that's a sort of a soft savings. Happy customers will, be willing to pay more and work with you more. You can improve employee morale because cloud-based resources are, more cutting edge. People feel like they're using the latest technologies, and they don't feel like they're burdened down by, by infrastructure. And otherwise, ability to move fast and increase global reach, again, can significantly give you a competitive advantage. Now, when we think about some of the hard savings and why we're struggling with saving them, then, we worked with the FinOps Foundation, and that's what they've been sharing, right? So one of the hardest things is getting engineers to take action. If you have idle resources, or if you have the ability to optimize, or if you can make your applications more stateless so they can auto-scale better, or if you need a report to understand if something's going to stay and you can buy commitments for, it's sometimes just hard to pass the human layer of it all. And getting your engineers to give you the right feedback so you can take the right actions. Dealing with shared costs. Cloud also turned many things into a black box for many organizations. You have to make sure everything is tagged, everything is governed, everything is visible. You have the right dashboards, you have the right reports, you have the right costs on top of it, and kind of what happens to the cost of running the platform. Your operations teams, your people that deal with cloud, procurement and management. If you're running a Kubernetes cluster, what happens to all the shared services in it? Not everything goes to the same person. If you buy reservations and there's waste, who pays for them? Some of these things are also a struggle for organizations today, and they kind of just end up in like a black box of like, this is more cloud cost that we don't know why we're paying. Accurate forecasting, again, very complex to kind of figure out when you have so many moving pieces, and being able to buy the right commitments or plan ahead accordingly makes you pay more per unit when you are not prepared for that. Reducing waste is a big challenge as well. And again, I think full allocation, I think that connects to what I mentioned on dealing with shared costs, making sure that you understand who owns what dollars. The cost of containers are kind of another layer of abstraction. So if the cloud abstracted your data centers and went into a full virtualized route, in containers, you're starting to virtualize the virtual machines in a sense, and you put another microservices architecture on top of it. Again, you do a shared service, you get more optimization. So again, we go to that soft saving of you reuse services and applications, but now it's really hard to tell who's paying for what. So you're paying less, but you don't know who to charge for it. Big problem for organizations. And then lastly, obviously, aligning the finance and the tech teams on all those plans and SaaS costs that come around it. But I really think that the core of it all is, how do you understand what's going on? How do you go to the right people with the right problems? And how do you get them to take actions on actually making the changes you need to improve on that? Now, what we see today is a lot of manual cost operations. So I mentioned kind of how the cloud costs look, and you're kind of in the experiment, adopt, they keep going up. Then after you migrate, you're able to start optimizing. They start going down, but they go up again. What we often see is that optimization is an event. Right, so you go back every 3 months, 6 months, a year. You might be able to do it in-house. You might call out some consultants from external spaces, and you optimize. And you kind of put some burden on everyone. You stop innovating, you stop building, and you start optimizing. You start figuring out how to make what you've already done operate more efficiently. Now, that's a waste of time, right? That's not differentiating for your business. It does improve margins, but as your business keeps growing and growing, every time you go back to optimize, it becomes harder and harder. And the way I like thinking about it is, as the world has moved from waterfall software development, where you released capabilities every few months, it was really easy to optimize with that. In agile development, in Scrum teams, we see releases happening a few times a month, a week, and even many times a day in many companies at this point. And if you optimize once every 3 months, essentially the very next day your code base looks slightly different. It's not significantly different, but the way I imagine it is like your developers are taking an axe pick and kind of just start picking into your optimization. And that's why you find yourself back at the same spot about 3, 6, 12 months later, where everything is unoptimized, or the unit economics are worsening and not improving over time. Now, the goal is to remove as much of that overhead, as much of that manual operation, and moving to as many autonomous decisions as possible inside your cloud, and as a sophisticated financial operating model for your cloud as possible. I believe the FinOps Foundation have defined FinOps not as financial operations, but as the world of development financial operations. Which is really Fin DevOps. And the idea is that when you want to operate your cloud finance as well, it has to be interlinked to how you work with your cloud, and it has to happen in real time. However, what we see is that people are dealing with ever-increasing complexity and a lack of time and resources to actually solve those problems. Also, by the way, if anyone has any questions about anything I'm saying, or you want me to double-click on anything, feel free to throw them in the chat. I'm looking at it. I'll make sure to respond as I talk, or kind of make sure I dive deeper. And as a small side note, prior to my strategy role, I used to run solution engineering here at Spot. So I have worked with several hundred DevOps teams and FinOps teams to date on figuring out how they optimize and how they approach it. So feel free to ask anything on the space, and I hope I can provide an answer. Now, moving a bit to the world of what do we actually buy from the cloud, and how can we start thinking about how we optimize it? So it's very important to kind of set the stage with the 3 purchasing models of cloud consumption. Now, this is using the AWS lingo, but this is also true for GCP and Azure. They actually all call spots in the excess capacity world, and reservations, commitments. But really, we have 3 main purchasing models for compute. And the reason we're focusing on compute is because we've noticed that about 70% of most of organizations' cloud spend is on EC2 itself, and is mainly on compute in there. So we thought that's probably the best place to tackle savings. The first method is on-demand purchasing. You pay for what you use, you scale it up and down based on demand. The cloud providers pretty much commit to have infinite capacity for you, but at the same time, it's very expensive per unit costs. If you would probably compare running that 24/7 for a few years to buying a piece of hardware, I think you would find yourself at 5-6 times the cost. And being said, you can really optimize that. Now, the first one, which we see most organizations adopting, is commitment options. AWS calls them reserved instances and savings plans. They'll give you anywhere from about 27% discount to about 63%, and you'll buy commitments for 1 to 3 years. You'll pay all upfront, no upfront, or partial upfront, as you can imagine, you do 3 years all up front, you'll get 63. You do 1 year no up front, you'll get 27, and then build the matrix in between. And the unit economics are much better. And you get, it's not that flexible. So you actually don't commit to spending those dollars over the 3-year period, but you're committing to spending an X amount of dollars per hour over that period. So if you're trying to burst up and down, or if you have a cyclical business model, you cannot leverage these type of commitments to optimize, because you will have to pay for them 24/7, 365, and then 1, 2, or 3 years of that. So because they're not always super flexible, if you're seeing some surges in traffic during holidays or during specific seasons, commitments are not the solution to optimize spend though. It's about 50% discount we see organizations are able to reach. Many of them don't feel comfortable with 3-year commitments, so they kind of stick to the 1 year and are satisfied with the 30% because it's obviously much better than the full price. One of the slightly lesser common models, but also increasingly adopted, is the world of excess capacity. So if we spoke about the data center cyclicality on the one hand, and then we think about the cloud provider's commitment to endless capacity, you can all guess that they face a similar issue, right? So 60, if most enterprises were able to leverage about 30% of their data center on average throughout the year, cloud providers are able to do a lot better actually, but it's still 60 or 70%. So about 20, 30%, 40% even of their data centers at any given time just sits there idle. They're paying for electricity, they're paying for maintenance, the hardware is running in case anyone wants to schedule anything on it. They're paying for real estate and everything in between to own that. And because of that, they're willing to sell that as excess capacity for 60 to 90% discount off the on-demand prices, but with no SLA. So that means that if suddenly one business is scaling up very significantly on a family or on a machine type that you're using as excess capacity, AWS or the cloud providers will reclaim it in any time between 30 to 120 seconds and simply shut down your environment, which doesn't tend to be a very good solution in production. It's most used for batch workloads, AI, all types of computing in processing models. However, it can be managed appropriately to run production-grade workloads, which we'll dive to shortly. And all of that brings me to the importance of continuous optimization. So as I mentioned earlier, in the worlds of CI/CD, you're constantly delivering software, you're constantly changing your code. Because of that, and you should also constantly and continuously optimize. As you deploy new applications, they should be analyzed, optimized, scaled, and you should then continue to operate, monitor, plan, code, build, test, release, deploy again. And really the world of continuous optimization means embedding those decisions around pricing models, scaling decisions, idle resource management, and all of that as your applications move. The more cloud native your applications are, the easier it is to continuously optimize them and make sure that as you deploy and as you make changes, you're also able to enact savings. Really, you should think about it as a combination of CloudOps, right? So on the one hand, you have DevOps, the people who are building your development operations. They're the ones making sure that your software and infrastructure builds are efficient, they're scalable, your developer productivity isn't hurt, and then when they want to put something in production, they easily can. Then you have FinOps, which, as I've mentioned, the FinOps Foundation has kind of defined it as financial DevOps, which are people who are in charge of making sure engineers are productive, but also that their cost is managed well and they're continuously optimized. And lastly, you want to make sure all of that is secure, and that's where SecOps comes into place, but we're not going to focus as much on that today. We at Spot here believe that FinOps should almost be delivered as a service inside the business. It should be easy. It shouldn't be burdensome. It should be something that makes your life smooth and happy, and it shouldn't be such a tedious task. We believe that with proper FinOps management and proper continuous optimization, you can reduce the cost of cloud infrastructure by up to 80%. I would say we regularly see numbers in the 60s and 70s. Really, you do that by automating and expanding the use of spot instances where possible. You run as much excess capacity and you don't make commitments you don't have to. And then you get the full value out of reserved instances and savings plans. You want to do that, again, with as much automation as possible, so you do it with as little operations burden as possible. You want to automate the provisioning of as many resources as you can, and also automate the process of purchasing commitments with your cloud providers based on the ever-changing architectural landscape in your organization. And then you would also want to make sure that as you do that, you delight your users, you delight your engineers, and for that you should simplify and accelerate cloud application delivery. You can automate infrastructure for containers and Kubernetes by auto-scaling based on real-time application needs, and instead of kind of doing capacity guesses ahead of time. And you want to bring continuous optimization, again, to as many applications life cycles as possible. And really, in an ideal world, we want you to get to a place where infrastructure looks very much like this graph on the right. So we think about the graph on the left, which is kind of it's already auto-scaling, it's already leveraging some cloud-native architectures and not running too many excess resources when you don't need them. But you mostly run on demand, and you can buy reservations for that baseline you never go under, but then you have to pay on demand for those ebbs and flows. And your compute is fairly homogeneous. So you kind of, we see that many organizations are going, okay, I'm compute intensive or memory intensive, so let me use the C5 or the M5 or the R5. But it shouldn't be an or question. It should be this and that, depending on your application needs, depending on the deals you can get on pricing of compute. And again, making all of these decisions in real time. Ideally, you end up with an infrastructure that looks a lot more like what's on the right. You get heterogeneous instance types, shapes, and sizes. You leverage all the different pricing models. You run a baseline of commitments and reservations or savings plans. You fall back to on-demand if you have to every now and then, but generally avoid them. And you run a layer of spot instances for everything that's bursting or not running 24/7. If it can scale up and down, it can usually run on a spot instance as well. And if properly managed, it can do so in production, which we've seen hundreds of organizations do throughout the years. And today I want to dive a bit deeper into the Spot CloudOps platform. So the Spot CloudOps platform really is a platform that tries to unify the capabilities around everything I just mentioned. And again, I want to think about it as a variety of workloads, visibility, and automation. Now, when we think about visibility, we think about tools like Cloud Checker or Cloud Analyzer. So that goes back to the first challenge we saw coming from the FinOps Foundation, which is how do we allocate costs? How do we know who's spending what? Obviously, again, there's some responsibility on the consumer to make sure that they get they take the resources, you're able to track them, you're able to tell what belongs to whom. Then with tools like Cloud Checker, or even at the basic level with AWS Cost Explorer or with the native tools the cloud providers offer, you're able to extract reports, understand how much each tag is spending. Is it dev? Is it staging? Is it production? Is it the analytics team? Is it the front-end team? Is it the back-end team? Is it, and if you're a larger enterprise, it's not free, right? It's 400, 500, 2,000 different teams that you have to figure out who's spending what. So one of the first things to do with the financial management of your cloud is visibility. You need to understand who are the biggest spenders, who have the potential to save the most. Tools like Cloud Checker from NetApp can help you with that. And then you want to deliver automation where possible. So after you've analyzed the full environment, with tools like Eco, we're able to purchase and manage all of your commitments. And now we want to start going down towards the application teams, or deliver as much as possible application-driven infrastructure. So we'll use tools like Elastigroup for compute, which you can think about sort of like an auto-scaling group on steroids that is natively aware to all of your existing commitments and is able to scale on spots once they're utilized. For containers, we can use tools like Ocean, which I'll dive deeper into in a moment. But then if we want to run Spark workloads, we should have a tool that can optimize Spark. If we want to do continuous delivery, we should have a tool that optimizes that. For security, again, we're not going to dig into that today, but we also offer Spot Security and Cloud Checker some compliance capabilities. And a lot of desktops, we also offer Spot PC for end-user desktop management in the cloud. And again, you want to make sure that for all your cloud providers, you get full cost visibility, you get full infrastructure optimization, and you do as many decisions as possible coming from an application-driven way. I just quickly want to share like one case study on what continuous optimization meant for an organization. This is a team, the global VP of infrastructure at Ticketmaster, when we had a talk at reInvent, when everyone would still get in person regularly. So reInvent in 2019. Ticketmaster are a massive organization, over 1,400 people in product and technology, over 1,000 nodes in Kubernetes, tens of thousands of containers. And they're able to do all of that with 3 operators. And that's because they've been able to leverage our platform as well as some in-house automations to build a completely autonomous infrastructure. Those 3 operators working together with Ocean were able to get the following results. They were able to deliver software for developers the fastest. It is the easiest platform for them to work on. Their costs were 4 to 5 times more efficient than anything else they've been able to do in the cloud when not using continuous optimization, when just optimizing as an event. And at the end of it, once they figured it all out, the operations overhead was significantly reduced. Those 1,400 people don't need to talk to those 3 operators. Everything is autonomous. They can push any type, shape, or size of application they want. And get the infrastructure they need in real time, because infrastructure scales and optimizes based on the application needs. When we think about Kubernetes, we think about container resource requests like CPU, memory, GPUs, disk needs, networking needs, affinities, anti-affinities, labels, stains, tolerations. Anything the application can declare on itself at the metadata level, you would want to make sure you take into account before you deploy infrastructure. And again, you want to make sure that that is as optimized as possible. From here, I didn't want to talk about, looks like this slide got a little fudged, but I want to talk about commitments management. Eco does that. You can also do some of it, or, to some extent, leverage some analysts or hire a FinOps team to do that in-house for you. But the idea is that when you buy commitments with your cloud providers, and slowly but surely, your cloud bill is probably becoming one of the largest bills your business is getting every month. Just like you wouldn't take all of that money you have personally and invest it in a single stock, or at least, well, any financial planner will advise you against that. This is not to be taken as a personal finance advice. But you also shouldn't take all of your money or all of your commitments with your cloud provider and put them in a single commitment plan. You want to make sure that you're reaching as much coverage as possible while maintaining some flexibility. You might be able to, your business might take a downturn, so you don't want to buy 100% coverage with 3-year commitments. The economy is a little shaky right now. As we know, global pandemics can hit and affect our business cycles. Maybe that's not the safest thing to do if you want to hedge some risks. But you can build the baseline of that. You're not going to churn 100% of your business overnight. Or even over a year or 2 or 3. So you can build a baseline with 3-year commitments. You can do some savings plans on compute, of both compute and EC2 for some of your more odd use cases where it's hard to track how many instances you're using because you're doing some ML in this region, some AI in this region, and different teams are experimenting with different GPUs or memory CPU relations or types of underlying CPU hardware. Compute savings plans are a great solution for those regions or for those areas that they can just cover anything. Obviously, they'll save you a little less, but they're extremely flexible. You then do some convertible arrays, so in case your footprint grows, you're able to convert the size of the commitment, but not necessarily change how much time is left on it. And then you try to leverage some standard arrays. And the reason for that is twofold. One is that they save you the most. Because they're like the hardest model to manage, they give you the most savings. But the one really important thing to remember about them and generally about your commitments is to buy some sellable commitments. The cloud providers, AWS mainly, allows you to exchange commitments through the marketplace, where you can sell it to a different business. We've seen a lot of these transactions when the COVID hit back in March 2020. Businesses that had to do with live events of sorts, or with in-person existence, took a big hit, while businesses that had to do more with virtual communications or with mobile gaming or generally gaming, saw a huge influx of traffic. Both of them, however, did not know how long this is going to last. The live ones or the in-person based companies wanted to get rid of as many commitments as possible in the short term. But it's not necessarily that all of those, online type businesses were ready to buy them, because they didn't know if this surge in traffic is going to last. However, having a marketplace strategy, the ability to convert and sell commitments allowed many businesses to hedge around it. Eco itself, our solution will obviously build that strategy for you. It will do all purchasing, converting, and selling of reservations on your behalf. Because we collectively manage several billions of dollars in cloud spend, we're able to take much higher risks as well, in a sense, because we are able to hedge that risk. We're able to know that we can buy for your business 100% coverage of a C5 instance family, because even though you're using 1,000 instances like that, we're managing 100,000. And if we need to get rid of a few hundred for you, we can always find a place for them in a matter of minutes. So Eco sells a sort of both an automation layer to not having to manage all of your commitment plans, but also sort of an insurance policy. So in case anything happens, Eco can get rid of them for you, whether that's a business change, by the way, because you're just modifying and re-architecting everything, or a true economic reason. With Cloud Checker, as I mentioned earlier, we're able to give you the full visibility to tie up together with all of our automations. The Cloud Checker platform will help you do all of your expense management, your price and usage, re-rating of all sorts, your cost BI, budgets, focus, dashboarding, and reporting. You can add all layers of shared costs into it and make sure that no dollar goes unnoticed and is properly governed on the spend. Again, the journey starts with visibility, understanding what you've been spending well, and making sure that the right teams are saving. Ideally, you want to make sure that your customers, and by your customers, I mean your developers, your DevOps teams, if you're a DevOps yourself, that's the journey you would probably need to go to. And that's the journey we take our customers through as well. Want to make sure you get connectivity and visibility on all the relevant accounts, so you understand what's going on well. You want to start by auto-discovering, analyzing, and monitoring all infrastructure and workloads, so you can have a better trace and sense of what's going on there. And then you want to start by providing a continuous optimization plan or how are you going to deliver automations that help them save. Next, you want to figure out the workloads that you want to start testing on. You want to start running your new methodologies with. And you want to track the SLAs, the performance, and the savings KPIs to make sure that this is running efficiently and as expected. And as you do that, start thinking through what would it mean to do this in production. In dev, maybe you didn't mind clicking through something. In production, you might want to do it with infrastructure as a code. You might want to put some more monitoring on it. You might want to take into account what will happen to your APM tools that are running there. And things like that. And then again, try to accelerate it as much as possible by leveraging things like infrastructure as code, CI/CD tools, and tying that together. And expand the use cases. Figure out what can actually support different optimization methodologies. Again, big data is approached in a certain way, batch processes in another way, production web apps in a different way, databases in a different way. You need the right tool for the right job. It's not the same hammer for every nail in this case. To dive a bit deeper into our products, I'm going to do that now. I'm going to try to not do it for too long, but Generally, Elastic Group, as I mentioned earlier, is sort of our auto-scaling group replacement. It's really important to mention everything we do as Spot by NetApp, we do in your own environments, in your own cloud accounts. We exist at the metadata layer only, so we get no access to any customer data, sensitive information, regulated data of any sorts. But rather, everything stays in your account, locked in your account, and we leverage the cloud provider's APIs to do the relevant manipulations. When you think about Spot instances, so when we run you with Spot instances, being the manager of maybe over 1 million of them at this point, running concurrently, but definitely several hundreds of thousands, we're able to start predicting and understanding the trends and behaviors in the excess capacity markets. Because of that, we're able to predict interruptions ahead of time and move you over to a different capacity pool. Every Spot capacity pool exists at the intersection of an instance type, shape, size, and availability zone. So the reality is that there's always excess capacity. There always was. Even on March 15th, 2020, when everything went online in a day, and the cloud providers went, everything got really hectic for them. There was still excess capacity. We've noticed many companies suffered thinking there wasn't because they weren't spread out enough. But all of our customers were safe. And the reason for that is that Elastic Group and Ocean by default will distribute you across the data center and will keep iterating until they make sure capacity is available. SLAs are always going to trump savings, so we're always going to prioritize resources uptime over leveraging Spots. Elastic Group provides predictive scaling and rebalancing. So what we normally see when you do leverage excess capacity is that even if you've gone through the effort of distributing your markets and making sure that, let's say you have 10 instances, you run in 5 markets, so 2 in each, still when one of them gets interrupted, you would experience the interruption and then scale back up somewhere else in order to balance it out. Elastic Group instead will predict the interruption ahead of time, provision new capacity, and gracefully drain the old resources to make sure that you're maintaining uptime and maintaining resource requests SLAs. And again, if there's no excess capacity available, we fall back to on-demand by default. Azure Spot instances, as well as AWS ones, will give you anywhere from 70 to 90% discount. Again, it's more of a game of finding where they are than whether or not they're going to save you. There's definitely savings there. They don't go below 60% almost ever, maybe to the 50s, rarely for specific instances in specific regions, but generally always available. AWS, once again, save around 70%. Azure and GCP are closer to 80 still. Next, I want to talk about Ocean. Ocean is another layer we offer directly for container optimization. Ocean can integrate into any existing control plane. So whether you're using EKS, GKE, AKS, your own flavor of Kubernetes, OpenShift, ECS on Amazon, Ocean can plug into your existing clusters and optimize your worker nodes running in them. Ocean does that with automating 3 different layers, which I think is really interesting. The first one is the automatic provisioning and pricing selection. So kind of everything I've mentioned that Elastic Group can do, we can choose the right Spot instance at the right time, we will leverage your reservations first, and we will scale up on Spots. And that's, I think, is fairly understandable at this point. Now, where Ocean gets more interesting is how it selects compute size and type. As I mentioned earlier, essentially you want to do application-driven infrastructure. So Ocean is not going to optimize you based on just running the same machine again and again. It's going to look at actual application needs and make sure that we're selecting the right instance type, shape, and size while honoring the pod requests on CPU, memory, GPU, networking, disk, label, stains, tolerations, network, storage. I've said that twice. And really playing sort of a Tetris game of getting the right instance type, shape, and size at the right time and getting them as packed on each other as possible in order to make sure you're as fully utilized as possible. And now we have 2 flywheels, right? One is choosing the right cost model at the right time, And the second is choosing the right instance type, shape, and size based on what the application is asking. But I'm sure that if I could ask you all here, how many of the developers in your organization you're guessing are rounding up the resources that they're making? I'm sure 90% or more of you would raise their hands. And that's the third layer we're tackling. Are your developers making the right decisions? Are they asking for the resources they need? Are they asking for 4 vCPUs because it's a nice rounded number? Does it not more reasonable that their application probably needs like a 3.65? And when you do that again and again and again, and all of your developers are adding 20, 30% more resources than they need, your cloud bill is 20 to 30% bigger. And if your cloud bill was $30 million last year, then it can be 40, if they do that, or it can be 25 if you make them optimize it. Now, Ocean will continuously monitor all of your actual application usage and then make sure to push out recommendations to optimize. Also, I know I'm talking a lot. Again, if anyone has any questions, feel free to throw them either in the chat or the Q&A page, and I'll make sure to pick them up. What Ocean really does is trying to optimize kind of the experience of how do you build containers, how you deliver them to production, as I mentioned with the Ticketmaster story. And we want to move the entire process of provisioning and managing compute, memory, and storage resources, and kind of have you focus more on building containers, deploying applications, and running and managing the applications while not having any waste. So I mentioned earlier about Eco. Eco makes sure to leverage the biggest cloud discounts with the smallest overhead and smallest waste. And we have countless of case studies where we were able to increase coverage to 95, 98%. We also have many case studies of how businesses have gone through different cyclical behaviors in their business and how Eco was able to help them through them with managing commitments more efficiently. And I think actually that's it for me. Is given I'm going to pass on security today. I think, again, the really important takeaways from here are try to automate as much as possible, try to leverage as many different pricing models as possible, and work on getting the right visibility in place. I think if you leverage those 3 main pillars for cost optimization and you're able to continuously do that, then your cloud will be as optimized as possible. And I'll open it up for questions from here. If anyone has anything, I'm going to hold on here for a few more minutes and answer. Please feel free to ask anything related to what I talked about or anything else you think I might be relevant for.
Hi, yeah, we did receive a few questions here. So first question we got here is, do we need to implement and use Spot Ocean in order to use Ocean CD and Ocean for Apache Spark?
No, so we're actually able to optimize these things independently. If you want to run production applications on Kubernetes, we can do that with Ocean. If you just want to use it, on Spark applications, you can just use Ocean for Apache Spark to optimize your Spark workloads. And if you just want to do it on CD, you can just do it on CD.
All right, excellent. Next question: is it mandatory to configure resource requests and limits?
It's a very good question. Yes, if you want your infrastructure to stay up. So long story short, Kubernetes can sometimes handle, and we've seen cases where applications don't have defined resource requests, and Kubernetes sometimes did okay with that, but sooner or later those clusters end up blowing up because there's a lack of communication between either the open source cluster autoscaler or our autoscaler and what applications actually need. Now, one other thing to think about is requests versus limits. If you think about like your business heuristics, maybe you are able to say, hey, all of my requests are X, but my limits are 1.2X. So I'm going to give some overhead to all my applications. I'm going to end up packing my server in a place where my limits end up as being 20% more than what this server has to offer. But I'm assuming that it's never the case for more than a quarter of my services go past the request into the limit, this way you can significantly reduce your infrastructure footprint while giving your applications the potential added overhead or buffers that they need, but eliminating waste. There is some risk to it, right? It's a business decision that you might end up getting some services throttled.
Great. Next question. Does Ocean support stateful sets?
Yes, Ocean does support stateful sets. I know it's a bit odd for people to think of running stateful sets on spot instances, but it is possible. And we are able to do that in production by converting them over and staying fully aware of any stateful behavior.
Excellent. Next question. Would Eco help me use savings plans even for just a 3-month project?
Yeah, so savings plans aren't actually offering the ability to be sold. So when you buy a savings plan, you're committing to spending an X amount of dollars per hour, 24/7 for the next 365 days. What Eco is able to do is kind of understand the influx is coming. So again, 3 months for us, we've normally seen either tax season or holiday season. And it's businesses that kind of really boom during that period. Eco is able to buy you standard arrays, knowing that we understand which one of our customers are going to have some regular arrays expiring, in a 3 months time, and this way we're able to buy them for you, and knowing that we can completely offload them when you need.
Excellent. Next question. How would you recommend using EC2 savings plans versus compute savings plans?
Yeah, so EC2 savings plans are kind of similar to standard arrays. They, I think, save you a little less, but are a bit more flexible. I would use EC2 savings plans when you're using the same instance type and you're going to use it for a long time. I would buy compute savings plans to cover any of these more odd behaviors in your environment. I know that they're the easiest purchasing button because they just cover everything, but you're missing out on a lot of savings. So I would kind of focus on using them, saying, I don't know, let's say you run a bit of infrastructure in Japan and you get 5 of these instances and 2 of that and 4 of this. So, because of some regulatory reason, you have to have something that's running in Europe or any other country like that, or any other region like that. Maybe you don't want to spend so much overhead managing it, but you do want to make sure it's optimized. Buy some compute savings plan to just cover all of the different types together. Buy the EC2 one if you're investing more heavily in a specific type over the others.
Great. Next question here. How do international customers use the marketplace?
Yeah, so international customers sometimes struggle with the cloud provider's marketplace because they need an American bank account for it. Usually the solution is to go to an external vendor. Admittingly, we do that for our customers, but I believe you can find some local MSPs maybe in your region, or some other types of vendors that are able to do that for you, and kind of mask you as a US entity in order to do these transactions on the US soil, in a sense.
All right, and if spot savings are much higher than any reserve capacity, why not use spot for every workload?
So again, as I mentioned earlier, you want to use the right hammer for the right nail, or the right screw for the right screwdriver. But the idea is that you probably don't want to run databases on spot instances. In most cases, they won't handle interruptions well. That's where you buy reservations. You maybe have a baseline you just feel comfortable committing to, and you don't want to run everything on excess capacity. That's perfectly reasonable. So you might be buying that. But the idea is, again, depending on the use case, you might want to commit to it, or you might want to run it on excess capacity.
And if more and more companies switch to using spot instances, would it not affect the overall availability of spot instances?
Yeah, so it's a very legitimate question, right? The more people use excess capacity, there's still going to be excess capacity. So I mentioned earlier, we're talking about 30 to 40% of the cloud providers' data centers. A lot of the people using spots use them in exchange of on demand, so it's not like they're using both, right? So they're releasing regular capacity and end up using the excess because they are not using the regular one. but the idea is, again, as long as you're able to be flexible and spread out across availability zones, instance types, shapes, and sizes, we've never seen an issue with capacity in any region, actually.
Oh, great. And the last question I see here is, how significant is the interruption during the switchover to a new spot or on-demand VM?
So we are able to, so the interruption should be seamless, right? So if your application is stateless, it's able to be drained, it has replications. So it's really important to differentiate between, just like highly available applications or not. So if they have replicas and if they have like more than a single point of failure, so it's not just about their state, it's also about the resiliency. A resilient application can withstand interruptions without feeling anything. You're going to close all sessions in the 2 minutes that you get from the cloud provider. If you rely on us, we might even get you to 15, 20 minutes, so you can close longer sessions as well. But the way you think about it is, right, you go into a web page, you downloaded that web page, it's local to your computer now. When you press a link, you go directly to the load balancer again, and you get rerouted. If the container or the instance you loaded the initial web page from is not available anymore, it doesn't matter. The load balancer is just going to send you to a new one. So as long as you can close those sessions in 2 minutes, that shouldn't be an issue at all. And there shouldn't actually be an interruption or downtime. If you're using a single stateful instance and you run it on excess capacity, and you're able to, reuse the volumes, the network interface, and relaunch a node with them, we'll be able to, we're able to do that out of the box. You can build something around it, maybe with some lambdas and automations, but it will look like a system restart, and that's roughly how long it should take, depending on how quickly your application can fire up.
Great, excellent. Great questions. Thank you. Thanks to the audience for submitting those. And we still have about 9 minutes if there are any additional questions. In the meantime, I did want to remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you'll be able to watch it again. We will be sending out a link to access the webinar on demand, and the webinar will also be available on DevOps.com. Just look in the on-demand section in the webinars page, and it should be there. I did mention at the beginning that we're doing a drawing for 4 $25 Amazon gift cards, so I'll go ahead and announce those right now. Our first winner is Jonathan A. Congratulations, Jonathan. Our second winner is Jean G. Congratulations. Our third winner is Jesse P. And our final winner is Wendy Q. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Just looking over the Q&A section, doesn't look like we have anything. So with that, Tomer, thank you very much for taking the time out of your night to give us an hour. It was very insightful, a lot of information. We really do appreciate it.
Yeah, thank you so much for having me, Julio. For anyone in the audience, if you want to chat about anything else, you can find me on LinkedIn. My email is firstname.lastname@netapp.com. Feel free to reach out with any questions, thoughts, or comments. I'll be more than happy to talk again.
Of course. And I'd also like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Take care, everyone.